welcome. I'm very happy you all came to this presentation where I want to talk about language workbenches. Now, how many of you know what language workbenches are? All right, not many. So my mission here is that after this presentation, all of you will know what language workbenches are and whether and how you could employ them on your current projects. So I would like to start my explanation of what language workbenches are and what they can do for you by showing you a product of a language workbench. And the typical product of a language workbench is an IDE. So I'll start with a demonstration of an IDE here. How many of you use any of the JetBrains IDEs? Cool. Good, so here's another one. One that you haven't seen yet, I assume. It's called the Voice Menu. And it is an IDE that is different from the other IDEs that you can download from our website. This Voice Menu, I hope it's starting, is a single-purpose IDE that serves one. Starting. Okay, that serves one purpose, and that is to edit voice menu definitions. I believe all of you have some sort of experience with voice menus. You call bank or some phone operator, and they have some automated sort of reply that system that gives you options like press 1 for your account balance, press 2 for invoices, press 3 if you want to talk to the operator, that kind of thing. We at JetBrains, we have a system like that. It's called Asterisk. Apparently they have about a third of the market of these tools. There are other vendors that provide telephone software that can provide automated responses to your customers who call in your office. And if you want to configure these, you are supposed to edit a file like that. This is configuration for the voice menu system. And here you specify how the menu is structured, and you attach audio files that are packaged and uploaded to the server, and then the server then follows the configuration here in order to reply to customers who call in your organization. And now imagine you've got an organization, and you now have a need to create such voice menu for your company. Who would you give that task to? Would it be an IT person who can understand this format and can edit it and work with it? Or would it be people from marketing or customer relationship department who understand the customers, who have done studies on how the menu should be structured, how deep it should be, how many options you should have, what should be first, what should be second in a menu. They also might have some marketing campaigns running, like for customers from certain region, you want to show them or give them certain advertisement before they actually can choose an option from the menu. So who would be more suitable? I mean, technically the IT people are suitable, but from the business side, it's the people from marketing or from the customer relationship department. So in the end, you will end up with people from both departments cooperating to build this. Now the trouble, this is a typical scenario, right? You've got a domain expert who understands the domain but cannot really write the code, and then you've got people who can write the code but don't really understand that well the domain, and they have to communicate and together end up with a solution. Now, it has its flaws, right? A typical problem could be, what if that domain expert person leaves and you get a new one? Now, from this, it's very difficult to understand the structure of the menu. Unless they keep documentation of the structure of the menu, there's no way for the new person to understand quickly the problem domain, because it's now scattered in the implementation code. So what we decided to do as a demonstration of capabilities of MPS, which is the language workbench that I work on at JetBrains, is to create a language. After all, it's a language workbench, so its task is to allow you creating languages. So to create a language in which a domain expert could directly encode the structure of a voice menu. So they will get a language that provides high-level abstractions that can automate the generation of that property files that's required. And the language focuses on just this domain. It cannot do anything else but voice menus. So here it is. Here I'm back in my IDE. I'll slightly enlarge the screen. And this is an IDE for that language. And it resembles all the IDEs from JetBrains, right? It has very similar menu structure. It has panels on the left side, at the bottom, on the right side. Here in the project tree, you can create new things and then edit them. You can delete them, click on them, they open in the editor. So the usual thing you would expect from an IDE. And then looking in the IDE, you can obviously edit the code here, right? So you can, you can start, typing the structure of the menu. So if you press button 5, then I want to do something, and I've got all the options in all IDEs. Alt-Enter will work here. Control Space will work there. You can highlight all usages, search for usages, go to definition by Control B. You can rename things, and things get renamed. So if you are fluent with IDEs from JetBrains, you feel at home. If you're not, which can be the case if the user is not a programmer but a domain expert who's never seen any of the IDEs, then they have different habits. And for that, the IDE has to be prepared, especially if the language is not aiming at programmers. This particular language doesn't aim at programmers, right? The typical user is not a programmer. So we provide various other ways to, assistance that are more familiar to people outside of the programming group. So like you've got this context menu here where you can just press the button you see right there, or you've got this panel on the right side which allows you to sort things and move them around using mouse. So I finish this option here. So here I have an option, set up the event, what should happen when the user chooses that option, and now down here I can choose the possible events, how to handle that option, if user chooses that. And now when the menu is finished, well, the user can just run, the code generator. That will effectively generate the code that we were meant to create by hand, in the first place. And so this is the code that will now be uploaded to the server. And all the text that is being written here has been converted using text to audio converter into audio files, and also packaged with that configuration file. So now it's ready for uploading to the server. So not only you get the IDE, but you get a dedicated, not only you get that language that's dedicated to the domain, but you get a tool for using that language. And that tool gives you all the features that you would expect from an IDE, like navigation, code completion, intentions, searches. Also, it gives you version control. You can possibly, but not for this language, you can do testing, or you can have that language integrated with continuous integration and have continuous integration server generate stuff for you, generate, the artifacts that you want to deploy can be actually generated at a continuous integration server. You don't have to do it in the IDE, just like with the other languages in other IDEs. And then there is this notion of code generator. So once you finish with implementing your voice menu, you hit a button that will generate the target, the implementation, which in this case is a property file specific to that asterisk type of software. Could be Java, could be C, could be anything that you can compile and run. So the task for the generator effectively is to translate from the problem domain, which here happens to be voice menu definition, to the implementation domain, which here happens to be a property file. So that's the task for the generator. So, schematically, you've got a language that someone prepares and wraps in an IDE, and users then use that language to build models, description of a solution in that language. And then you've got generators which grab that model and generate some output, some generated code which you can run or deploy somehow. Plus, there might be obviously, sort of Java classes or other, code that your generated code relies on. So you're not generating all the code, but you generate, code that might rely on some libraries or code. Like in this case, we rely on library that takes text and generates it into audio format. there are more options. Not only I have to generate that asterisk property file format, but I can generate XML instead. So instead of that property file format, now I got well-structured XML describing the menu. And I could use that for another tool. So, we can assume that there's another tool for voice menu that doesn't accept that asterisk-specific property format, but wants to have an XML document. So we can generate alternative formats to adapt to various tools that we may be using in our company. Or we could use that XML as input for code analysis. We could have an analysis tool that takes XML description of a state chart of a voice menu and will detect unreachable nodes, for example, or can detect too deep menu structures. So that's an alternative output from that language. Or we could choose HTML. And now I generate HTML, which can serve the purpose of documentation. So at the same time, when I generate my asterisk code to upload to the server, my continuous integration server can also generate documentation in the format of HTML, which can be uploaded to the HTTP server. And so the people inside company can look and see the current structure of the voice menu at any moment, and it will be always up to date. It's a generated artifact. It never gets out of sync with the code. Well, and my favorite, I can generate Java code. And that Java code can be then run, and it will serve as a simulator for the voice menu. So provided the audio is set up properly, now we should listen to the voice menu.
Welcome to GeeCON, the best Java conference ever. For schedule, press 1. For speakers, press 2. For practical information, it is best to stay in the city center and travel by metro using the yellow line. We will show you some proposals later here. Going to the previous menu, welcome to GeeCON, the best Java conference ever. Choose from this menu. For schedule, press 1. Choose from this menu. For day 1, press 1. Choose from this menu. For making it count, press 1. For cracking the code to secure software.
So you got the idea. So I now have, for my little language, I effectively have 4 different generators. One of them serves as the real generator for code I want to deploy and run. Then I've got a generator that generates documentation from the same code. I've got a generator that generates XML that could possibly be used for code analysis, or maybe used for other type of voice menu software. And I've got generator that generates Java that here serves the purpose of being able to simulate the voice menu before I commit into master and deploy to the server. So this was an example of a modeling tool. Well, what I've shown you, this voice menu IDE, that is a modeling tool. It serves one particular purpose, define voice menu, and it gives you a lot of assistance and generation. Now, what makes it different from the other modeling tools that are out there is that it was created using a meta modeling tool. So we did not start from scratch, but we grab a tool, the purpose of which is to allow you to create these modeling tools. So a language workbench allows you to quickly and easily create tools like that. To give you some idea, this project, this voice menu IDE, was created over summer by 2 interns that joined JetBrains, and it took them 1.5 months. They worked together, and they started from 0. They had no previous knowledge of MPS, so they spent like 2 weeks learning MPS, and then 1 month together to implement this system. So, the assumption or the promise of language workbenches is that it becomes easier to create such tools. So then it pays off to create these tools even for languages or domains where previously it wasn't feasible because the problem domain was too small. There wasn't the critical mass of community that would generate enough frameworks or tooling for that particular domain. So even in-house, now companies can build IDEs serving their core business, just for them. So just to wrap it up, language workbenches are universal domain-agnostic meta-modeling tools. So like factories for IDEs, or factories for languages and tooling around them. And there are several on the market. Some of them are open source, some of them are commercial. MPS is one of the open source ones, so you can grab MPS from GitHub or download it and use it for free, even on commercial projects. And obviously that's the tool I know best because that's the tool I work on. So I'll be speaking mostly about MPS, but the other tools, they allow you to do very similar things. So they allow you to create new languages or improve languages and customize them to your needs and then combine them when you use them for programming. I actually want to show you another example of a product that was created with MPS, so another IDE. This time it's much more elaborated. It's been developed over several years by about 10 developers, so definitely there went a lot of effort into building that tool. But again, this is not MPS. This is an IDE built with MPS. And this is an IDE for embedded software development. So the code, maybe you recognize it. What programming language is it, do you think? If you look at it? C, right, that's C. So, embedded devices, embedded software. How many of you have ever used any embedded software? Right, I believe almost everybody should raise their hands, right? If you go to an elevator and you press a button, there's some computer reacting to that. Typically, it's an embedded piece of software somewhere. Even a coffee machine, they have software. Typically, it's written in C. So for programmers who create that software, this IDE was created. So it offers basic C editing support, just like all IDEs. But in addition to that, the language has been enhanced to allow for more. So you can have math notations in C. If you do some mathematical computations, you don't have to use ASCII symbols. You can use math symbols. And it will generate normal C code that C compiler can compile then. So now, you can still call this modeling. I mean, what I'm doing here, if I'm editing this code here, I'm doing exactly the same thing that I was doing here while I was creating this voice menu. Right? It's exactly the same process. I'm building some code, it's just different language. And here we have the tendency to say this is modeling because it's just not a programming language. It's some description declarative language. While here, when it's language like C, it is an imperative language, it's a general purpose programming language, so we call it programming. But essentially, there's no big difference. I'm building some model or some sort of source code. I can call it either way. The process is the same. Now I've got a tool, the sole purpose of which is to allow you to edit C code with additions, like these math notations, or you can extend C code, the type system, with physical units if you do something that requires physical units. So let's say you have some positions, some metric system, to maybe position of a robot inside of some area. So you can annotate your types with meters, and then the type system is able to complain whenever you compare meters and non-meters. So now the type system becomes more insightful about your project, about your code. So it can complain whenever you compare meters and kilograms. While just plain C would, for both values, would give you, let's say, integer as a data type, and so the type system would not be able to detect issues like that. Or since embedded software is a lot about states and state machines, now they created dedicated syntax for state machines. So you've got a table, in that table you've got states and events, and then what happens during a certain transition. So if in certain state you get an event, what should happen? So the code is organized in a table, while normally you would have to do it with nested ifs or switches, and that what happens when you try to generate this code, right? When I do generate, I get plain C code with nested switches and if statements. But for programming, this is more efficient because the language is higher level, so it should be easier for me to understand the structure of the code. So there are basically there are two domains where this approach matters. This approach gives you advantage. First, it's a domain where there's a lot of repetition. So you have to change a lot of things in your code base to achieve certain change. Now the generator can do all these changes for you from just one little change to the model. Well, in the second area, that is when you need to raise the abstraction level. You're not happy with that, let's say the asterisk format, you need some syntax that's more intuitive for people to use. Okay, I've prepared 3 more examples of real usages, how customers use this approach to their benefits. So the first one is a very interesting project. I never thought that software could be used this way. It is a state organization in Netherlands who calculates regularly every month all the taxes that are due and all the social payments. So what they have to do, they have a running system in C# that every month generates like payments, you know, how much which company should pay on taxes. And in order to generate these payments, they have to implement law in code. So they have to implement all, you know, the law as it passes through the legislation process. They have to implement it in their software, and that's a pretty painful process because the code tends to be complex. It tends to change quickly, and you have to react to it. And also, you have to have the system has to support the history. So sometimes you have to calculate taxes, 10 years back. So you have to have, how the tax law was 10 years ago. So they created a set of languages and tooling for them as well, obviously, that mimic the language of legislation. And using these languages, they have legal experts who understand law and are not scared of computers, obviously, to encode that in the programs, in the models. And then these models then, generate C# code, which then runs. So as they were implementing these regulations, they realized, because the code must be non-ambiguous, they realized there are contradictions in law. So law had to be changed as a result of trying to implement law in a computer language. Because then it becomes obvious, right? The validator will report issues if there are contradicting situations where there's non-deterministic situation how to calculate taxes in certain cases. And surprisingly, they also have unit tests. I would never have thought that it's possible to unit test law, but that's what they do. So you simulate, you like mock-up scenario, like I've got these people, they live together, they have that many kids, that many, such and such income, such and such property, and I expect they should pay this much in taxes. And that's your unit test, that's your expectation, and the system will verify it against the, against the rules. So that's one case. Well, another one is an insurance company. They've got a department of finance experts who understand insurance business, and they used to write their rules in Microsoft Word. Has anyone ever written code in Microsoft Word? Don't be shy. I mean, you would be brave, right? It's very difficult. There's no IDE support whatsoever there. Yet that's what they had to do. So they wrote code, right? They created, well, one rule from in their system would look like that. It would be a page where it has a name, it has some sort of return type, some parameters out of which it computes the value, description, and explicit prescription on how to compute the value. And then they would send it as PDF and send to an outsourcing company for manual translation into C code, because their core system runs in C. And then that C code will send back for integration with the system. So there was a lot of manual processing, and I can imagine it was a nightmare if you got C code that did not work, or did you realize that your proposal was wrong, you had to fix something in your Word document and then repeat that whole cycle, and how to keep the versions and how to keep branches. I think that was quite difficult, and one of the reasons why they decided to use a language workbench for that. So now they created a language that looks like what it did before. Why reinvent the wheel? If they have a syntax they will understand and they're happy with, let's keep it. Just add the IDE bells and whistles there, like error highlighting. So if there's an error somewhere, I would like to see it in red, right? Maybe I would like to have code analysis that tells me something is suspicious in yellow. I would like to have code completion. I would like to have intentions, refactorings, and some basic support like that. And now when they press F9, it will generate C code for them, so there's no way to go, no reason to go to an outsourcing company for creating the C code. C code becomes an artifact. So this is what is stored in version control. Well, the last example I have is from aerospace industry. If you ever happen to work in that industry, and if you want your software to run on Mars or on some satellite, you have to go through a very rigid process how you write that software. And for good reasons, obviously. Any mistake there can become pretty expensive. It's difficult to fix errors there. So you have to write very formal specification. You have to track all the requirements, where you meet them in your code. You have to document your processes. And also you have to integrate with infrastructure code, which is not always very intuitive. If you want to communicate with the navigation system of the, of the satellite or other systems, you have to integrate well with the infrastructure code. So can language workbenches help there? I've got a few examples from the, this IDE, the embedded software IDE for C programming, because they did something along these lines which can show you the power of this approach. For example, documentation. Now, if you want to write documentation, and if you don't want to spend most of your time doing documentation, because in this field it is required to write tons of documentation and properly track it and always have it up to date, then the best way is to do it right in the IDE. So we've got a set of languages that serve the purpose of creating documentation which have a generator associated which generates PDF or LaTeX, whatever is required from these languages. And these languages, since they are right there in the IDE, they can have live references to your code. So right there, I can just, here is a reference to some data structure track point, which is some C data structure. I can Control B on it and get to the definition. So here it is. Now I'm in my code. Now I can change things here. What if in this data structure I no longer track time in seconds but in hours? What if ID is no longer ID but identifier? And what if there is a new field, maybe a string kind of field, foo? So I change the structure. I mean, nothing unusual for changes in any programming language if you use an IDE. But for documentation, typically you would now have to open some sort of Word document or some other Confluence page or something where you would update your documentation. But not here, since the reference is live. It has been updated already. So the reference from documentation to your code is live. You can make changes to your code, your documentation, the references, that makes sense, get updated automatically. And for requirements, well, here's a sample requirement document for some sort of computer game, flight simulator. So a requirement document, again, let's do it right there in the IDE. A set of languages in which you specify requirements. So you've got sections, each section has a title, some description. And now you might be interested, like, hey, this requirement, is it used somewhere? Here I've got a requirement number 2, which says, once a flight lifts off, you get 100 points. So when I take off from the airbase with my flight simulator, I should be given 100 points. Is that particular requirement already implemented? Well, if you use our IDs, there's a shortcut called Alt F7. What does it do? Right, find usages. So let's do find usages. Who's actually using that requirement? Is it used somewhere? And it is. It's used in other parts of documentation, and it's also referred to from code. From here, for example. So here is some constant, 100, named takeoff, which refers to that requirement. That's probably quite related, because I should be given 100 points when I lift off, and here is a constant which says take off 100. Okay, could be related. What's the other usage? Well, here in the before state, but before flight. So when we leave that state, so when we go airborne, here's an exit handler. Add 2 points, the value of takeoff. So basically add 100 to my number of points. So exactly the implementation of that particular requirement. So correctly, these 2 places implement that requirement, and I can visualize that. I can highlight the traces of requirements right there in the code. I think the font is too small to read for you. So here it says, well, this particular line implements this requirement. I can hover my mouse and will read the requirement to me, so I know what requirement is actually here being satisfied. I can add more, right? Just add comma and pick some more requirements from the list that are actually being implemented by this particular thing. And I can Control B, and it will get me to the requirement. So very nice and convenient. Oops. I lowered the font, unfortunately. Let me fix that. Right, so I've got live references from code to requirements, so I can easily track requirements, and I can always guarantee, or I can generate report which says, well, these and these and these requirements are yet not implemented, or I can always see what piece of code implements what requirement, and if I change requirement, I know where to change things because I know which pieces of code implement that requirement. So we've got requirement tracking for almost free, instead of doing that manually, which can save a lot of effort. And you can, with your requirements, you can be even explicit because this is language workbench, so nothing restricts you to using just prose. You can embed code inside your requirement. So where you want to be specific and precise, you can. So let's say you want to specify that the points you get at certain track point of your flight should actually be computed using this formula. So you can just type that formula there. So depending on the altitude and the speed that you have at that track point, you'll get points. And here's basic, an easy decision table which says, well, based on that altitude and that speed, well, this is the number of points multiplied by some constant, and that's the point you should be given. And you can just test it right away. Here you can write a few tests that verify, certain cases. So for this and this altitude and speed, you should be given 200 points. So you can write a test which is constantly being interpreted. So if I change it, now it highlights it in red telling me, wow, this is wrong value. The interpretation calculates a different value. So you've got a feedback here telling you, whether your specification makes sense or not. So you can write, test it right there. Okay, well, there are more users that go this path and that found the approach based on language workbenches useful for their business. And actually, there's no domain-specific. You can't find a single domain which would be the only domain for language workbenches. They tend to be universal, so they are now used in several different domains. And each domain differs, slightly different features, slightly different capabilities of the IDEs that you can build with language workbenches. But if I try to sort of find the common benefits for all, it's these three. It's the productivity when you write code, it's the quality of the code that you actually have in the end, and leveraging the expertise of the people you have in your team in a better way than the standard approach. Right? And now I'm saying this applies to certain domains, right? It's not like solving every problem of every single programming domain. It's probably not currently applicable to web development because the tooling there is already good enough, so the benefits would not be that visible. But if you target to domains like embedded software development or writing software for satellites or law, then the benefits are great because the tooling currently there is quite pathetic. So, well, to look into these three main benefits, well, the first one, the productivity, right? If your generator can generate a lot of things and you have to track requirements manually, the alternative is to do it manually, documentation, track requirements. Now, having a generator that can generate all these things for you and having an IDE that can keep all the references for you, that can save a lot of effort and a lot of time. So, assumably, you can proceed faster once you have that tool available, but obviously you have to spend some time upfront to build the tooling and the languages so that you can even start. Luckily, most workbenches have support for language versioning built in. So you can start with incomplete prototype type of languages. You can already start development, and you can create a version 2 of your language, and then as soon as people get the new version of your language, their models, their program gets updated to the new version of the language. So something like if that worked for Java, you could, and you have code base in Java 6, then you download Java 8, and then migration would just turn your inner classes into lambdas where possible. Right, so something like that you can have for languages in a language workbench. Then, the quality of the code is also quite I mean, this approach tends to offer high quality of the code that actually results, that you get as a result. First, because typically you code on a high level of abstraction, where it's easier to spot problem-specific errors. For humans, if you do code reviews or pair programming, and also for computers, if you have static code analysis tools. You can have domain-specific error messages, like in the voice menu. I guess I did not show you, but if you make an error, like you provide the value that's not available on the keyboard of a phone, you get a warning right there in the IDE telling you, hey, that is not available on a phone. That is a very specific domain specific error. Right? That's just for this domain. You've got an error that's specific to that domain. You can have a language that avoids dangerous constructs. So you can even go that far that you create a language where it's almost impossible to create invalid code, which sometimes makes sense, sometimes it's too restrictive. It's obviously always a trade-off between flexibility of that language and safety of that language. But you can decide where the trade-off lies for your particular case, your particular domain. Well, and the third, and I think most importantly, you can leverage expertise of your of your people, both the domain experts who understand the business and also the programmers who know how to implement that business in code. Because now you separate the two things. It's not like both mixed in one chunk of Java or C code, but it's separated. So the knowledge of your domain experts or the legal experts is contained in language that resembles law. So you can have people who understand law to grasp the essence easily and to make modifications or ask for modifications more precisely. And then you've got the code generators, which are the domain of us, programmers. So this is the place where we put our expertise into. So how to actually implement that logic in this particular implementation domain. Now, one important side effect of this is that you've got consistent quality of your code. So if you've got new features, like new business rules in your system, the quality of their implementation will be the same as the quality of the old features, because the generator is the same. So it generates code with the same number of defects per line of code for the whole code base. So it's not that new features need to be more buggy than old features. Obviously, there are risks, right? There are risks that have to be taken into account if you try to use this approach on some parts of the applications that you work on. Well, first, there's this upfront effort that you have to spend in order to have languages, in order to have the IDE support. So that can be eliminated or lowered by proceed gradually. So you start with first version of a language and you evolve it as you go. Obviously, you also need someone who understands language design. And that's probably the biggest obstacle, because this profile is hard to find. People who know how to define languages, how to evolve them, how to make languages usable and intuitive. This is even if you look at universities, right? There are not many courses that teach that skill. So this is pretty rare profile. And obviously, as with all new things, there are cultural challenges, because things have to be done slightly differently. Although we try to put all the effort into making things as smooth as possible, if you try to integrate, let's say Java code base with code that is generated from some high-level business domain-specific languages, so you can use Git, you can save your models alongside your Java sources. You can use the same continuous integration servers. You can do unit testing the same way. There are still some glitches somewhere if you need to integrate things. Some things can be, or some things are different. So and these differences have to be overcome. And yeah, sometimes it's worth it, sometimes it isn't. Okay. Before I finish with a few pointers for documentation, I would like to actually show you the language workbench itself, because so far I haven't shown you MPS. I showed you several usages of MPS. I showed you the voice menu system, which was created with MPS. I showed you the embedder system, the set of the IDE for embedded software development, but I haven't shown you actually MPS itself. So, time to show it to you. So, I'll show this project. Okay, so this is MPS, just started, just like all our IDEs. So that's a language workbench. And I use it to create a new project in it. And since I'm a programmer, I don't need any wizard, so I start with an empty project. So here it is. It looks like IntelliJ IDEA or WebStorm, whatever. You've got the project structure on the left side, and then big pane for the editor, and some more panels on the sides. But this is a language workbench. So it is a language, it's a tool that allows you to use any language or create languages and then use them. So it's like an IDE for any language that you can imagine, and, well, you have to create it. So just like in all IDEs, you structure your project code in modules. So I can create a module for my UI code, database code, whatever, however you want to structure your project into modules. I've got my first module here. And inside module, in Java, you would package your sources into packages. In Ruby, you would structure it into folders. Well, here we invented some name that should work for all languages. We call it models. So now instead of what you call package in Java, here we call it what you would call package in Java, we call it model here. So I can create a package or model demo A, and one more. Model demo B. So now I've got two models next to one another. Right, and these, and now I should be able to create code in them. But, well, unlike in other IDs, here I have to say what language I actually want to use. Right? There's no default language. You can use any language that is available to you. So you have to first import the language you want to use. So let's use Java, which happens to be called base language in MPS because it's used like the foundation, the bottom line for all development here. So we call it base language, but it is Java in a sense, precisely, just copy of Java. So now I can create, now I've turned my MPS into a Java IDE. So I can create a new class, foo, public static void main, SOUT, hello world. I can compile, run, just like in IntelliJ IDEA. So I turned MPS into a sort of IntelliJ IDEA. Or I could turn it into a Ruby IDE in a very similar way if there was Ruby implementation for MPS, which there isn't. But there is implementation of XML, so I can import the XML language. And now I can create not only Java things, but also XML files. So I can create a simple XML document. Whatever, XML document. Or I could just go to the plugin repository and download some more languages. There is, and I've already downloaded the ECMAScript, so pretty much JavaScript prototype implementation by Marco Lombardo, who created it. Well, it's still in a prototype stage, but since I've downloaded it before, I can use it. So if I import, it into my model, I can now do JavaScript programs here. So I can type JavaScript. Not quite. Right, just JavaScript now, not going any further. But, well, so far I was using MPS as sort of an IDE for any language that I download and decide to use. But obviously the main power is in being able to create languages. So I can create an extra module that will be a language definition. So I can just, here now I created a definition of a new language, which I could also import in my model to use it, but since it's empty, it doesn't give me any new functionality yet. And you see that definition of a language involves several steps. There are several aspects of language definition that you have to sort of implement so that your language can be used. So you have to define the abstract syntax first. So you have to say, whether your language contains an if statement, a while loop, method declaration, or whether you want an XML element, or some decision table, or state machine table, and all that thing. So that would be the abstract syntax. Out of what nodes I can actually compose my programs. Then you would define the notation, the editor. So how will people edit my code? Will a method signature look like in Java? So type, name, parameters, or will it be more like the keyword, the def, name, parameters, colon, type? So that's the problem of notation, right? You have to decide how the code looks like to the user. And well, type system. Will I have types? Will there be values? Will they have types? What types? And what is a subtype of what? So that would be another part of language definition. And finally, generator or generators. So I want that language to be translatable into HTML or Java or C# or more at the same time. So that would be the task that you would give to the generator. Okay, we don't have time here to actually go through an implementation of some language construct, so I won't proceed with that. Instead, I'll finish with a few pointers to where you can look for more information. Obviously, this project is open source, and it's documented. You can go to the website. We've got tutorials, so you can learn a lot from there. And you can also get books that can tell you more about the technology and how it's meant to be used. Interestingly enough, the first book, which can be considered to be a very detailed reference book on how to use MPS and what knob does what, it was created by a guy who's not a programmer, who's a biologist. Because he simply needed a detailed description for his students to use that tool, to learn how to use that tool quickly. And it illustrates the main target of tools like this, right? They do not target the mainstream programming area, like web development, mobile application development, because the tooling, the community there is huge. So there's a lot of great framework, a lot of great tools. And this approach will not give you that many benefits. But for domains that are much smaller, where there is not large community that could provide you with open source frameworks and tested tooling, then this is the area where this approach can actually bring interesting benefits. Okay, well, that's all I prepared. I hope you enjoyed this presentation at least as much as I did. Thanks for having me. Okay, I think we have time for questions, right? Yeah, okay, so yeah, we can have 1 or 2 questions.
I want to ask, you mentioned basically that we are designing new languages. So are there any limitations on the language in terms of the category, basically? Is it context-free or LR1, LL1, or what has to be the language that we are designing?
Mm-hmm, okay. Yeah, thank you for that question. Okay, well, I haven't mentioned that, but this, MPS is built on projectional editing. Projectional editing is an idea from like 1970s, where you actually not edit a text that needs to be parsed, but you edit a tree, abstract syntax tree, and the editor only gives you an illusion of text or table or diagrams, right? You can have basically any notation you like. So if I look at this piece of Java code, which looks like text, I can actually suppress the editor and ask MPS, hey, show me the truth. What is behind? We call it reflective editor. And so instead of seeing the text, now I see the tree. I see the abstract syntax tree of that piece of code. Well, I can go further. I might want to see the tree for this as well. So now I know this was expression statement, where the expression is this. And I can go even further. Reflective editor, so it was a dot expression on this operand, and then this operation. So you see, I'm gradually revealing the abstract syntax tree nature of the code. So and then the textual part, the textual thing, is just an illusion. It's like one of possibly several projections how you might want to look at the code. So for example, for the voice menu, you can quickly switch from this notation to a notation that is more tabular, because it's just replacing one notation for another, but the AST, the model stays the same. So effectively, you have languages that are tabular, textual, form-like, diagrams. You know, the notation is up to you. So pretty much any syntax could be expressed. Anything that could be laid out on a, you know, on a pane, on a graphical pane on a computer screen. And yeah, and you could probably go even further and imagine editors that are not restricted by the screen, but would allow you for gestures or voice or some other type of input, if it makes sense. You know, I don't know if that would make sense, but you're not really restricted to parsers and text here. Oh, does it answer your question? All right, good.
Yeah, but you still need a regular expression or something to define this. What's valid in the tree, or how do you define that?
All right, well, that goes, yeah, okay, thank you for the question. All right, okay. Okay, well, that's not, okay, I'll answer your question. Your question is how it's actually implemented. Well, it's implemented, the concept, the abstract structure is defined on object or in an object-oriented way, right? So, for example, an if statement, I'll go here. So an if statement in Java is defined, come on, takes a while, but it's defined, here we go. So this way you define, you know, concepts of a language on the abstract syntax level. So, and that would be similar to even to textual editors, right? So you say, oh, well, if statement has children, has a, you know, has condition and has two children, one for true branch, one for else branch, and then there might be several else if branches. So this is Java's if statement on an abstract level. And on the notation is not defined in terms of grammar or parsing, because you're not actually inputting when you type code, you're not actually typing text, you know, and that needs to be parsed. Whatever I do in the keyboard is effectively an event to the abstract syntax tree at the position where my cursor is, and the tree will react somehow. So, for example, if my cursor is right here where I am at the end of, you know, behind the semicolon at the end of the line, and I start typing, then nothing is happening. Because this is actually a user interface. It's not a textual editor that would just accept whatever I type in and then try to understand it with a parser. But instead, it's reading my key strokes and reacting to them. And since there's, you know, since the notation for Java doesn't allow any text here, then nothing is happening when I type characters. And when I do backspace, then it cannot delete the semicolon, because then it wouldn't be valid Java. So just highlight, delete it all. So it highlights it for me. Well, this will be deleted if we continue like that. Okay, yes, I do one more backspace, and it deletes it. So, you know, sometimes you see that it's not text, it's really just projection of a tree. And to define for the if statement, okay, back to the if statement, to define the notation, we use a language. You see, we use that concept of languages even for language definition. So there's a dedicated language that might resemble grammar definition remotely, and that sort of indicates how an if statement should be projected to the user. So there should be some keyword if somewhere, then there should be condition in parentheses. But, you know, if you don't like it, you can change it. I can just remove parentheses or change them with square brackets, whatever I like. This is just, you know, notation thing. And this is not a grammar for a parser. This is more like a prescription, a layout of cells, how to put them on a screen, on a Java Swing canvas. So it's like a language, how to put parts of that if statement on a swing canvas. All right, yeah, time is up. I hope I answered at least partially your question. Obviously, that's, you know, that would require more time to answer. I'll be available to answer any questions you may have offline. So thank you for coming. I'm very happy you came.